Today, I want to see what you guys can do. And often, I see what your scores are on Khan Academy, and I see your notes of what you do. Well, that's cool, but I want to see what you do so I can help you and understand. So I did make a Desmos and also a worksheet. We need to have both open because the problems are going to come from the worksheet. I didn't have enough time to add the problems. So if you guys can go to the pace, which should automatically open for you at 11, and open up the worksheet. Um, and I wanted to put these problems in the Desmos, but I didn't have enough time. And also open up the Desmos, student Desmos. Okay, I'm gonna open up the teacher Desmos, but you open up the ones that student Desmos. All right, let me take a peek to see how many of you guys are on there. I can see that I went on YouTube. Well, I went on YouTube and I found the video of the Robotech transforming to create the analogy. The analogy. Wait, is that the link? Hold up, I think I put the wrong link. 1 second.
What?
Teacher Desmos. So you guys are in in student Desmos, correct? I think I put the wrong link for me. But I can log in quickly. All right. Let me see. So then I go to my custom. So I make these custom made ones. Here's factoring. It's called factoring quadratics. That's what we're doing today. So I'm gonna go here and change my link. My link was wrong. I had the YouTube of a Robotech. Okay, so we are in factoring. I can see 5 of you guys are in. And so here we go. We have Shiv, Sophia, Hannah. All right, so let's all go to the first one. And I'm going to take you there because there's a reason why I want you to be there. Okay. So in the first one, I found a video on YouTube and I had to learn how to download it and then upload it here. We got 3 forms of this airplane. We have the airplane, we'll call this standard form, right? And then it converts into this half, we'll call that vertex form, right? So standard form is the airplane, vertex form is like the half and half, and then the robot is factored form because he's on the ground. So anyway, it took me about 10 minutes to figure out how to download YouTube. And of course, I went on YouTube to find out how to download on YouTube. All right, so we're going to do, and I think I've shown you this example before. All right, so I'm going to move you guys to screen number 2. So everybody be on Desmos for now, okay? And go ahead and play the video on screen 2. And I have a better way. I made this one like a year or so ago, and I have a improved version. So go ahead and watch this video, and with sound, of course, right? Go ahead and do that, and I'll wait for you. You can mute your audio so you can have your own uh, sound. I turn on.
Everybody, here's how.
Now this is actually a hard one, and I purposely made one that had a lot of options, a lot of numbers. And let me know when you guys are done. Okay.
She has no idea.
Yeah, go ahead and turn off your mic for now. Thank you. And when we're done, we'll put the mics back on so we could hear your questions. Okay, cool. Thanks, Savannah.
All right, I'm good.
Thank you. Yep. Okay, guys. So this was a little review, a little bit because you've done this yesterday and the day before. Factoring is tricky. Now, like I said, in this one, I picked one that was kind of a hard one because 36. There's a bunch of numbers that multiply 36, but only one of them they add up to -9. And I had to do guess and check, and that's the only way you have to guess and check. All right. So remember, we're converting. We're making this airplane turn into a half and half robot. Okay, it's the same thing. All right. So next, what we're going to do is go to screen. Let's see what screen 4 is. Let me open this up. What is screen 4? All right. So can you guys type in the function, and I'll read it to you. The original function was x squared minus x minus 36. And then type the factored one, which was x plus 3 in parentheses times x minus 12. So type both in and see if it is the same function. If it's the same function, that means you will only see one graph.
I think two things were typed on my screen.
Oh, it's already typed? Oh, okay. I was trying to get into the student version, but I couldn't figure out how to get it down. Okay. All right, so it's probably is typed in. Let me just kind of click on somebody's. I'll click on Travis's. When I made this, yeah. So I did type it for you. So I apologize. So basically, it's saying that they're both the same function, right? It's the same robot, airplane, or whatever. Okay. All right. So if you typed it wrong, it would have been you would have seen two graphs. Okay. All right. So number one. So on this worksheet, we have r squared, and we can change all these to x's. It doesn't really matter. So you're going to have r squared minus 6x plus 5. So, and I'll go ahead and do one of these with you. So I'm going to do the box. See, I should do it on Desmos with you. Okay. So I'm going to pick. So r squared is going to go here. And I'm going to go ahead and write at the top the whole thing. It was r squared minus.
Shouldn't it be in, then why are you writing down an x squared?
The variable doesn't matter. So we could use r. Good question. We could use any letter, right? So I could put r minus 6 plus 5. Okay. So I'll go ahead and do r squared. Now the original one was r squared minus 5r plus 6, was it? Let me check it out. Okay, I don't know why I can't remember these things. And then plus 5, minus 6, and then plus 5. Okay, so the two that you start off with are these two. So go ahead and write both of these in there. And these two have to add up to negative 6r, which means they both have to have r in there. So what two numbers multiply to 5 and add up to negative 6? Can anybody help me out with that? Multiply to positive 5 and add up.
Maybe -5 times -1 for 5, and then like -1 plus -5 for like -6.
Exactly. So -5 times -1 does multiply to +5. And when you add these, they did add up to -6. So there is guessing and checking here because you could have, oops, you could, well, with 5, there's only 5 and 1, right? And then you basically do the box in reverse. So what you want to do on the right side, you want to put in parentheses r minus 5, close, r minus 1. And by the way, if this was a function, like right now it's not a function, it's just an expression. If it was a function, what would the x-intercepts be? Or the r-intercepts? What would the r-intercepts be? So it'd be +5 and 1, right? If it were the x-intercepts, right? If it was a function. Okay, then the x-intercepts. Go ahead and write. I guess you can write all that. Yeah, I think it's gonna type it. Oh,
I just wrote down the equation.
yeah. Right now it's that. Okay, all right. So that's number 1. Let me take a peek and see if you guys are all doing this. Good job. I can see now a lot of people that aren't signed in with us, and then they go in 2 days later, a week later. A lot of people don't do this. So I'm giving you points for every screen you do, and I'm not really sure why the people that I don't really, because the instructions are on the page. You have to listen to the video for you to know what to do. Okay. All right. Good job, Sophia. So if it was a function, then the x-intercept would be 5 and 1. All right. Right now, it's not a function. It's just a basic expression. All right. Now let's go to number 6. Let's see what is 6. I don't even know what 6 is. I think you gotta type this stuff. Let me see. Make sure, yeah. So go ahead and type the functions. Now I'm not sure if it'll r was it -6x? Well, r plus 6 plus 5. Yeah, so go ahead and use x's because Decimals doesn't like r. Okay, so you're gonna do x squared and then minus 6x and then plus 5. And underneath that, write the factored one, which is x minus 5, x minus 1. And then notice that they're the same function. Go ahead and change one of those to a different number, like +1, and you can see that it's not going to make the same function. See, it's a different graph, right? So it's got to be the same one. All right. Let's do one more together, and then I'll let you guys go on your own, okay? So number 2 in the worksheet, you know what I'm going to do? I'll have them on my computer. So this one we have, and go ahead and change the r's to x's. This way we don't have to worry about it, okay? This one's going to be x squared plus 3x minus 4. So go ahead and convert that one to let me move you guys to number 2. Go ahead and convert this one. And this one was x squared plus 3x minus 4, okay? I'll even write it up here. X squared plus 3x minus 4. Now, in the future, I'll try to have the equations already written in here for you. Okay. Go ahead and factor this one. This was still a pretty easy one. This was really like almost identical to the one right before it. So go ahead and factor it, and let me see what you guys are up to. And I'm here to help you guys. So if you're stuck with one, if you're not sure, okay. Good. I can see everybody. And the benefit of watching this video later is that you can see my screen and I can see everybody's work, and you can see, they can see what to do. But I'm not sure why students aren't doing it. Okay. Okay. All right. Good job. Good. So what two numbers multiply to -4 but add up to 3? Okay. Good job. Hannah said 4 times -1. There we go. And then Hannah, go ahead and put the x's inside that 4 and -1, because those two will have x's as well. Just trying to like be real picky about that. And same thing for you, Hayden. I always forget to also the x's. It's not really a big deal because this is sort of like your work, right? Um, yeah, so Hayden, don't forget to put your r's inside that 4 and -1 inside the little boxes. There we go. Put little r's in there next to the 4 and the -1. Good job. Okay. So it would not be wrong because this is basically your scratch paper. Does that make sense, everybody? Like the box is basically just your thinking. Um, Now I can actually do these without doing the box. I just do them in my head. But I've had a lot of years of practice. Um, the box is really convenient too, especially if you're going to be taking IM3 next year. We do the same thing in IM3, except the box will be bigger. It won't be a 2x2. It'll be a 3x3. So the box is a really good way. All right, so go ahead and move on to. I'm gonna allow you guys to go to. I'm gonna unrestrict everybody. So when you're done, go ahead and go to the next one. And the next one, you just type in both functions just to make sure that they are right. Okay. And notice that it doesn't matter if you put x plus 4 first or x minus 1, because when you multiply two things, the answer is the same. So all I want you to do is you're going to do 10 of these problems. We got 2, so you have 8 more to go. Take your time. Okay. But I do want to see your work, and I want to be here to support you. Okay. So take your time. All right. And when you type both functions, make sure that there's only one graph showing. Okay, because if you have two graphs showing, it means it wasn't the right one. It wasn't a robot. And go ahead, like I said, I'll be here and I'll be real quiet. But if you guys stuck with them, go ahead and I'll probably log out at 11:30, and then you guys just continue. Um, the number 7, 8, 9, and 10 they're a little harder because there's a 25, so that one gets a little trickier. Uh, but it's the same process. They're still guessing and checking. Okay, some of you guys are moving on to the screen 3, number 3, problem 3. There you go. Problem number 3 was pretty easy because it was 10, which is 5 and 2. Perfect, right? Real simple. Some of these are really easy. You can just, right? Good job, everybody, on number 3. Good job, Savannah. Perfect. 5x, 2x. So you guys are getting the idea. As you know, I'm taking a stats class at Sierra College, and yesterday I spent 4 hours doing one homework, and it is really hard. I know how to do it. I just don't know what it means. So what I want you to know what you're doing here. You're factoring it so that you can find the x-intercepts. Really easy. Okay, and you can verify that. Okay. Actually, I'll give you guys double points for this assignment if you put the x-intercepts on the right side of your answers. Okay, you can start with number 3. Okay, so if this is a 20-point assignment, I'll give you 40 points. So on the right side, when you finish your factored, you can just say x-intercepts, -5 and -2. Okay. You can put x int, and then you can put -5, -2, right? Because that's really the goal here, right? That's the only reason that you want to factor a quadratic, so that you can get those x-intercepts.
Hi, I was a bit late. What should I be doing in the first three?
Yeah, no worries. So the first three, the first thing was a video of, of my Robotech, right? And what you want to do is you want to open up the worksheet on the agenda, and that's going to have the problems, right? Thank you for asking. So then if you go to screen 5, which would be the first one, look at my computer. You're basically going to factor it out. And on the right side, or when you type in, you're going to tell me what the factored form is. And then you can tell me that the x-intercepts would have been this. Now, Nathan, these are not functions, right? They're just equations. But we're going to treat them like functions for the practice. Does that make sense?
Okay.
And then I'm going to give you guys double points if you give me all the x-intercepts, just on the side,
So I noticed on the assignment agenda screen that it said to only do screens 1 to 16, even though they don't quite.
Oh, they don't line up. Yeah, let me. Thank you. Let me fix that. Thank you. What screen is number 10? Let me find out. Thank you. Number 10.
You should probably put the daily agenda on the new classroom instead of putting it on only the old classroom.
24. Okay, hang on one second. So it's going to be 1 to 24. That's a lot of screen. Well, we started with screen 5, right?
Probably also put the daily agenda on the new class as well. So
the new class. Oh,
yeah,
I see. I got you.
Class.
I got you. In the Google Classroom.
Yeah, the new Google Classroom.
Yeah, I'll put it. Yeah, and I'll put it right on the top, so it's right there. Good suggestion. All right, guys, go ahead and continue to do this while I'm here. I did pick pretty simple ones, just so that you're not getting any curveballs right now. Let's see, material. And like I said, keep in mind that the main idea is we're trying to convert standard form to factors so we can find the x-intercepts. Later on, I'm going to show you a different way to find x-intercepts, but this is actually a really easy way. If the numbers are easy, it's way faster than the other method I'll show you. All right, Travis, I did put the agenda. It's going to be in the very top. Little by little slides down. I just have to keep on pushing it up as time goes on. All right, let's see where you guys are at. And on the graphing, you just have to type both to make sure that you're good. It's like a way for you to visualize what you're doing, okay?
Of the job that
All right, I'm going to pause you guys real quick before I leave. I'm going to take you to number 7. All right, and can
All right,
you?
what's going on?
Yeah, I'm going to take you to number 7. I'll bring you guys back. Okay, so go ahead and look at my screen. Actually, I didn't have to pause you. All you gotta do is look at my screen. Number 7 is really it's different, but the same. Okay, so go ahead and look at my screen. The function is now. Also, I stopped giving you guys the little rectangle, the square, because I wanted you to draw your own, right? So number 7 is 25x squared minus 35x plus 12. Now, so we need two numbers that multiply not to 12 because there's a 35 here. You actually have to multiply these together. So when there's an extra number up here, then you have to multiply with the 12, and that is 300. Okay, so we're thinking of two numbers. Now you only got to do this extra step when there's a number out here, because this also is going to change things. Then we need two numbers, the same two numbers that add up to negative 35. So just by looking at this, I know they both have to be negative numbers. Okay. So I'm going to start with 25x squared here, and then 12 here. So what two numbers add up to 3? Multiply to 300. Okay, let's see. 300 is 3 times 100. But if you add 3 and 100, you're not going to get 35. So that's not going to work. Let's see. 60 times 5 is 300. But if you add 60 and 5, you're not going to get 35. That's not going to work. So then there's 15 and 20. Those multiply to 300. And if you add them, they do become 35, except they both have to be negative, okay? They both have to be negative. So it's going to be negative 15x and then negative 20x. This was a little harder. So now, then you're going to figure out, oh, okay, what numbers divide into 25 and 15? 5x. That means this is 5x. That means this is negative 4, because that's 20. 5 times 4 is 20. And this got to be negative 3. So my factored one here would be 5x minus 3 times 5x minus 4. So the review here is when there's an extra number out here, when it's not 1, then you have to multiply it with the last number to get what you need to multiply. Okay, and we're going to spend more time on this one. So I'm going to have you guys just try these out, and then tomorrow we'll crank these out more. Okay, this is the hardest that it gets. Okay, so.
Stop meetings were only Monday to Thursday.
Yes, Monday through Thursday. So on Monday, thank you. So I should have paused you guys instead of forced you guys to go to my screen. So go ahead and go back to where you were. And then I'm going to go ahead and log out now, and you guys continue to work on here. And if you want to stay here, you can help each other out. But yeah, thanks, Travis. Today is Thursday, so I'll see you guys on Monday. Okay.
All right, I guess in that case, I'll be leaving the chat myself.
Okay. All right, everybody.
Guys.
Thank you. But make sure to finish all these by Sunday. Okay, Travis?
Yep.
Okay. All right, bye. But everybody else, just since you're here, just try to get as many as done. Because on Sunday, I'm going to type in the grades for this assignment too. Okay. So number 4 is pretty easy. 5 is easy. 6 is easy. So 1 through 6 are pretty easy. 7, I gave it to you. So basically, you just have 3 of them that you'll have to like push yourself through. Okay. Remember, you're guessing and you're checking, right? You're guessing and checking a little bit.
So we're supposed to put the x-intercepts for all of them?
Yeah. So I'm gonna give you double points for doing that. Okay. And don't forget, Nathan, technically they're not x-intercepts. They're basically the x's that would work, right? If you look at that worksheet, those are not functions, they're just equations. Well, those would be the answers that would work, right?
Okay.
Does that make sense?
Yeah.
Yeah. So the difference between a function and equation, well, an equation only has one or two answers. A function has millions and billions of inputs, outputs, right? And by the way, this is how I check to see your score. If you want to look at my screen, I can see who logged in and then what screens you've done. So that's kind of how I check to see who's done what. Okay. So if you only do a few of these little white bars, then that's the points I give you. And then, of course, I open a few of them up and make sure that you did the work. Let's see. Good. Okay. Number 4. Good job. If you guys were on number 4, and those are twins, did you notice that? You could have also put x plus 4 squared, right? Devin, since you're on that one, Devin, can you put that x plus 4 squared since they're twins? There you go. And that looks like vertex form. Make sense? Okay. Oh yeah, you got to move to the right. Yeah. So this one says there's only one x-intercept, or you could say there's two x-intercepts, but they're the same number. All right. So you can just say -4 is the only true x-intercept. Perfect. Yep. Good job. And when you guys graph it, when you see the screen on the graph on screen 13, you see that the graph just touches the x-axis perfectly at -4. That's it, just one spot. So try to explore, like, what's going on, right? Very good. And that looks like number 5 is also twins, right, Sophia? Right? And you could tell they're twins. By the way, I can look at this in twins. If you get half of -10 and you square it and it becomes 25, then that's how you know you're twins. If the middle number, halved, is when you square it, if it's the last number, then it's going to be twins. Good. And Hannah, since you're there, all right, you can also put x minus 5 squared, right? So since they're the same number, you can also put x minus 5 squared. And that's basically factored too, in a way, right? Make sense? Because it's the same one, right? It's kind of like a lazy way to say the same thing. And then when you graph it, pay attention to that it only touches the x-axis at 5, right? Excuse me. Good job. Sophia, Hannah, yep. Yeah, Sophia, you notice how in your graph you have two different graphs? And the reason we have two graphs because it should be x plus 5, right? The x-intercept will be -5, but if you have x plus 5 times x plus 5, you'll only have one graph. Yeah, there you go. You fixed that already on your own. Good job. Okay. Perfect. Okay. And then Shiv, for your number 7, the x-intercepts wouldn't really be 3 and 4. They'd be 4 divided by 5 and 3 divided by 5. So can you fix that? Because if there's a number in front of x, then you have to divide it by the. So take a look at that. Does that make sense, Shiv? On number 7. So the x in, because 4 wouldn't make -4 disappear, because 4 is going to have to multiply to 5, which become 20, which means we have to get 4 and then divide it by 5. And then if you multiply that by 5, then you would get 4 minus 4. Yep. So there you go. So we put 4 over 5 and 3 over 5. And you'll see that when you graph it on the next one, that one of them is going to be 3/4 and the other one's going to be negative. And when you graph it, you'll see it's going to be 3/4 and then 0.8. Wait, never mind. Not 3/4. 3/5 would be 0.6 and 0.8. Yeah, these x-intercepts are you have to divide them by 5, right? You have to undo the multiplication. Good. And then watch. Click on those x-intercepts, and you'll see what they are. See. All right, guys, you're 70% done. If you're on 7, okay, take your time, put some music on. Good. I can see everybody's graphs are perfect. This is really good. You guys are doing really good. Good job. And a lot of you guys are number 7. And don't forget that the x-intercepts won't be 4 and 3. They'll be 4 divided by 5 and 3 divided by 5. Good job, Sophia. So you're on number 8. So you want to multiply 9 and negative 8. And so that's going to be negative 72. So that's it. The two numbers have to multiply to negative 72. So I want to write that somewhere. Now, they have to add up to 6. They got to add up to 6. So what two numbers multiply to 72, but yes, somehow adds up to 6? That means one of them is going to be positive and one of them is going to be negative. Let's see, 72. Well, obviously 9 and 8 add up, multiply 72, but they don't add up to 6. Let's see, what two numbers multiply 72? To multiply 72. Well, 2 and 36 that multiply at 30, but they don't add up. Okay, so what you could do here, when it's really hard like this one, for 9x squared, you can guess that maybe it's 3x and 3x on the outside. Just maybe it's a guess, right? You're just guessing. So 3x and 3x to make 9x squared. There we go. So now we're just going to guess the rest, right? So then you're like, okay, what's going to make 8, right? What two numbers multiply to 8? Well, probably 4 and 2, right? So you can put 4 and 2 on the outside. Now, this is just a guess, right? You're going to put a 4 somewhere, put 4 on the top and negative 2 on the bottom, right? And then you're going to have you're going to have 12 and 6. Hey, that there you go. That gives you a 6, right? You're going to 4 times 3x, that's 12x. All right, 4 times 3x. So you're going to have 12x in the inside of the square. And then you're going to have 3 times negative 2. That's going to be negative 6. Okay. So this was a guessing check. And by the way, 12 times 6 would have been 72. It would have been kind of hard to get that right away. So now you have your factored form. 3x plus 4 times 3x minus 2. Now it works because 12x minus 6x is 6x. Yep. So this was a tricky one, all right? And if you guys want to, if you're at number 8, you can look at my screen. Sophia and I were kind of guessing this one. First, we're trying to figure out what multiplies 72, but adds up to 6. Good. And Sophia, the x-intercept would actually be negative 4/3, right? Because it's got to be opposite of 4. So we put a negative 4/3 and then a positive 2/3. There we go. Perfect. And then you can verify that when you graph it on the next screen. You can see that it is going to be negative 1.33. So when you get to problems like number 8, they take a little exercise. Good. 70 to 85. Good job. And then when you graph it, you'll verify that your x-intercepts or your answers are those. Assignments, marks. 285. Okay, good job. On this one right here, number 9, all you need is a 1x2 box. Okay. So you would just need a 4, Sophia. Put 4x on the right top box, and then 4 on the outside. So you wouldn't need the bottom part, right? So when you don't have 3, there we go. That's it. Perfect. So the answer would be, yep, 0 and -4/3. Perfect. Good job, Hannah. Yep, you don't need a different box for that one. They're in the home stretch. Last one. All right. Okay. Yeah, Nathan, you got that one. So they multiply. Yeah, that's very almost like the very first one, right? So multiply to 6 and add up to negative. Wait. Multiply to -6 and adds up to -1. So I think it's going to be a 3 and a 2. All right. 3 and 2 multiply. Well, Nathan, they have to add up to -1. And -2, 3. Yeah, I don't know if that's going to work. That one. And I think it's because on the bottom you put the two numbers. You have 2 and -3. Is that right? Is that a 5? What is it? They have to, yeah, 2x and 3. See, those two have to multiply. They have to add up to -5, and 2 and -3 don't add up to -5. Right? That adds up to -1, which is what you want. Yeah. There we go. So you should have a 2. It should be a 2 on the outside on your left bottom. Yeah. Put a -6 on the bottom. No, wait, hold up. There we go. Yeah, but that doesn't make sense. Mm-mm. No, let's see. Yeah, I don't know. 2n times 1 makes 2n. Let me see if I could do this one too. Let me jump on somebody's. Let me look at Sophia's here. So it adds up to -6. Okay, yeah, there we go. So yeah, oh, I see. Nathan, you were good. I was just your handwriting threw me off, and it's not your handwriting's fault. Just I couldn't see that. Yeah, these two add up to -1. Perfect.
Writing with the mouse is hard.
Yeah, no, I definitely agree. Yeah, and also I was a little confused myself, right? All right, so then you'd have 2x minus 3 and then x plus 1, right? Is that what you got? Yeah, 2x minus 3. Yeah. I think it's x plus 1, right? And you should have n minus 1. It should be x plus 1 because the 1's positive. There we go. Yeah, there you go. Cool. Good job, everybody. This is pretty impressive. All right, and that was number 10. All you got to do is graph them, and then that's it. And that's how you would know for sure, right? Perfect. Okay. Yeah, see that, Nathan? If you had a -1 in here, then it would have been off, right? Anyway, have a good weekend, Nathan. I know
Bye.
came in late and got done first. Okay, good job, Sophia. Okay, good job. Okay, have a good weekend, Sophia and Hannah. Just graphing the other one, and you'll verify that they're the same. Yeah, it should be x. Is there a 1 in here? Yeah. Perfect. Okay. Good. And then Hannah, don't forget you have to have another set of parentheses here. I think it's going to be x plus 1, I believe. You're probably doing it. Yeah, you probably. Why doesn't it? Have a good weekend, everybody. Okay, I'll post this so if people are stuck, they can watch the video and it shows Sophia, Nathan, and Hannah pretty much most of their problems. Good job, Colin.